Okay, this video is going to be for Math 120, and we're doing an intro to Chapter 7, and we're making a shift from regular statistics to inferential. Inferential. I can't even pronounce it. But descriptive statistics is what we were doing before chapters 2 and 3. Descriptive is basically based on data. Descriptive test scores, heights, the frequency distributions, meaning the tables that we had describing how many people fits in this category, how many people fit in this category. So we call that frequency distributions, and we would get our mean, median, and mode based on these forms of data. So we would get our statistics from data table, and the data would be in form of whatever we were given. Now in chapter 7 we're dealing with what's called inferential statistics. And inferential is when we infer something or we predict something based off of data given not in this form but in the form of a sample statistic. I like this is my own personal. We take a sample and prove how close the sample prediction is to the population. For instance, we take a sample at the Anderson campus about smokers, student smokers, and we find out that, and I'm just making this up, 28% of students at the Anderson campus are smokers. Inferential statistics will take that number and run it up the flagpole, so to speak, for the population, which would be Tri-County Tech in general. And what would be, based on this number, what would be the statistics, or what would be the measurement of smokers at Tri-County Tech as a whole. Now, in order for inferential statistics to work, there's got to be several things that we have to have. The first thing is called a point estimate. That's the first thing that we need, a point estimate. And a point estimate is basically sample proportion, and it's given by p hat, and it's the best point estimate of the population proportion. So when you talk about point estimate, you're talking about p hat, and that's the little caret symbol right there. We call it p hat. And usually that is given, or the information is given to establish p hat. The second thing that you want to have is a confidence interval. Confidence interval is basically telling you how confident you are that the sample proportion is actually predicting the population. I guess you would say you won't always be 100% confident, but usually the confidence interval is, the confidence levels run from 90 to 100% or 99%, because you don't want to go into meeting and say I have a 75% confidence level, because if you have a 75% confidence level, then really your data or your work is not really that reliable. So you want to have at least 90 to 99%. And a lot of people say, what about 100%? Well, nothing's perfect. And I don't like to tell students that it's easy to obtain 100%, because that's very difficult in real life to obtain 100%. And the last thing would be the sample size. What kind of size do you need in order to have a certain percent confidence level? In other words, if you want a 98% confidence level, how many people do you need to go out and what's the sample size that you need to have in order to obtain a 99% confidence interval? So these three things we will go over, and what to do to get those three things. Like I said, usually the point estimate, or p hat, is usually given in the problem. I'll give you an example of a problem, and that is the Pew Research Center conducted a survey of 1,007 adults. 1,007 adults. And found that 85% of them know what Twitter is. 85% of them know what Twitter is. Okay, so 1,007 adults were surveyed, and basically want to know 85% of them. 85% of them know what Twitter is. Now, the point estimate we can get from this basically is 0.85. And that's what we are given. The point estimate is 0.85. So p hat is equal to 0.85. And that's given. So in some of your questions that you're going to be given, they will give you what you need in the question. You just have to find it and pull it out. Now, the reason for the confidence interval, of course, is to be confident in your prediction. How confident are your statistics? How confident is your how confident is your point estimate? Now, like I said, the best thing to do is go from 90 to 99%. There's also the term alpha. Alpha is basically the complement of your confident level. So if we have a 90% confidence level, that translates into a 0.10 level for alpha, because 90, or 0.9 plus 0.1 is equal to 100, or 1. So if I have a 95% confidence level, that translates into a 0.05 value for alpha. If I have a 99% confidence level, that translates into a 0.01 value for alpha. And I tell students to do it all the way from 90 to 95. So I'll put in a couple of more. If you have a, let's go between 93% confidence level. Well, a 93% confidence level translates into a 0.07 value for alpha. And a 97% confidence level translates into a 0.03 value for alpha. Now, you're going to need alpha over 2 for some of your calculations. So what I like to tell students is make you a card and have 90, 91, 92, 93, 94, 95, 96, 97, 98, 99. And then have your corresponding alphas, and then have another table over here called alpha over 2. Alpha over 2 here would be 0.05. Alpha over 2 here would be 0.035. Alpha over 2 here would be 0.025. And so on. And fill those out also. Okay, so go ahead and fill you out a card and make sure you get those values, and you're going to use the confidence level to find your confidence interval. Say like if I give you the 85% confidence, the 85% point estimate, and we talk about a 95% confidence level, then your alpha is going to be 0.05, and you take that 0.05 and you work it into your calculation with the confidence level to get your confidence interval. Let's see, we're talking about a 95% confidence level, and that would be estimated for the proportion of 0.85, and then you would take away and add to get your confidence interval. So we'll get into that in just a little bit. And the last thing, of course, that we talked about is the actual, well, I thought there was one other thing I was supposed to cover. Hold on just a second. Sample size, and we'll talk about that after we find the confidence level. So, there's a couple of other things that you need to know about in this section, and that is the critical values, as well as the hypothesis test, and we're going to get into that also. A critical value is the number on the borderline separating the sample statistics that are likely to occur from those that are unlikely. And that's where you get your alpha over 2. That's where we start using the alpha over 2. So alpha over 2 will be used to find your z-score for your critical value. So make sure you make a note of that. Let's take a look. It says find the critical values, z of alpha over 2, corresponding to a 95% confidence level. Find the z of alpha over 2 that corresponds to a 95% confidence level. Well, that's going to be z sub alpha over 2, 95% confidence level. Alpha is equal to 0.05. Therefore, alpha over 2 is going to be equal to 0.025. All right. Now that 0.025 is going to be, I think, 1.96. When you look in your handy dandy table, look up 0.025. 0.025, that's going to be 0.0250, 4 digits, so that means it's going to be a 0.0250, there it is, 1.96. So your z-score for a 95% confidence level is equal to 1.96. Now, that's going to play into your confidence interval and all that good stuff. You take, let's see, 1.96, z is equal to 1.96. The critical value, therefore, is 1.96. And then to find a critical z-score, be 0.9750, yeah, that would be your critical value is 1.96. So that's your critical value. Okay. Margin of error. Margin of error is basically what makes up your confidence interval. Margin of error, I call it MO, is going to be equal to Z sub alpha over 2, meaning your critical value, multiplied by the square root of P hat Q hat over N. Now we know what P hat is. P hat is your proportion that we started with, your point estimate. Now if P hat is your point estimate, then what's Q hat? That's your complement. Q hat is the complement for P hat. So whatever P hat is, Q hat is going to be the complement. N is going to be the number that's given. That's going to be given. Usually your P is given. Usually you have to find the Q, which means you subtract it from 1 or 100. And then Z statistic is based on the confidence interval, and you find alpha over 2, and then you find your Z statistic. So, quick example. Let me find a quick example for this. And I don't see an example right offhand. It says in the chapter problem, we noticed that Pew Research poll of 1,007 randomly selected people showed that 85% know what Twitter is, and okay, the sample results are N is equal to, that's equal to N, and P hat is equal to 0.85. Alright, it says find the margin of error that corresponds to a 95% confidence interval. Find your MO at 95% confidence level. Well, that means alpha is equal to 0.05. Therefore, alpha over 2 is equal to 0.025. Alpha over 2 is equal to 0.025 will give us a z-score of 1.96. That's our critical value. That's our z sub alpha over 2. Now we know from our previous formula right down here that we need that 1.96 right there. So margin of error is equal to 1.96 times the square root. P hat is equal to 0.85, therefore Q hat is equal to 0.15 over 1,007. And you crank all that out on your handy dandy calculator, and you should get a number of 0.022 or 0.02. I'm going to just say 0.02 for our problem. So your margin of error is equal to 0.02. Now this is going to be a plus or minus of your at 0.85, so just get out 0.022. So just hold on to that margin of error, because now you're going to take your P statistic, which is going to be P, and you're going to add 0.85 plus your margin of error and 0.85 minus your margin of error. So B is going to be, P is in the middle, and I'm sorry, it's not equal to, sorry about that. And then on this side you're going to have 0.85 plus 0.022, and then on this side you're going to have 0.85 minus 0.022, and that's going to give you 0.828 less than P less than 0.872. And this right here is what you call your confidence interval. All right, now the C portion of the problem says, based on the results, we can safely conclude that more than 75% of adults know what Twitter is. Yeah, because ours is 0.85. So anything between 0.82 and 0.87 are likely to contain the true population. So we are more than 0.75. So, you know, it does appear that we're okay with with the 85% or more than 0.75, that people know what Twitter is. And the last part of the question, it asks, assuming that you are a newspaper reporter, write a brief statement that accurately describes the results of this information. Well, basically that 85% of people know what Twitter is, and we have that, you know, based on a 95% confidence interval, and we're talking about only 2 points either way. 2 points. So, you know, you're talking 83 to 87%. So you're pretty confident that you've got a 95% confidence interval and you're falling 82 to 87%. And you feel good about yourself, as the old saying goes. So, just to review, you have to have p hat, which is your point estimate. You also have to have your confidence interval, confidence level. Your confidence level is also going to give you alpha and alpha over 2. So your confidence level is very important, but your confidence level is usually going to be between 90 and 99%. So I would highly suggest that you make a card and make sure you put 90 and go down to 99% and give the alpha over 2, and if you wanted to, maybe even give the z-score for that alpha over 2, so you'd already have all of that information on the card. That's one thing that I would do. You also got to know your sample space, or we will talk about that, or sample size. We'll talk about that in a minute. We just went over margin of error, and sample size usually comes after margin of error. And your confidence interval, which is going to be P, and it's going to be less than or equal to your margin of error added on one side and your margin of error subtracted on one side, and then of course your critical value, and the critical value is based on your z-score, and you figure that with the alpha over 2 multiplied, yeah. Okay, so that's kind of an introduction to 7.1 and 7.2. The only thing that I haven't covered in 7.2 is the sample size, and when the p estimate is known, when p hat is known, you use this formula. N is equal to z sub alpha over 2 multiplied by, squared multiplied by p hat q hat over e squared. And then if p hat is not known, you're going to use, for your sample size, n is equal to z sub alpha over 2 squared, and then instead of p hat and q hat, you're going to type in 0.5 and 0.5, which is 0.25, and all that over your margin of error squared. So the only difference in the two is these two right here. And this is when you know p hat, and this is when you don't know p hat. And you just plug and chug your numbers in on that, and you will be able to get the sample size needed for a certain confidence level. Here they ask you, it says Gap, Banana Republic, and America Online are just a few of the many companies interested in knowing percentage of adults who buy clothing online. How many adults must be surveyed? How many adults must be surveyed I done lost my place. How many adults must be surveyed in order to be 95% confident that the sample percentage is in error by no more than 3 percentage points? So 95% confidence that your margin of error, or that you sample percentage is in the error no more than 3 percentage points. 3 percentage points. Okay, so we plug and chug. 95% confidence level means a 0.05 alpha divided by 2 is 0.025. We know that that translates into 1.96 z-score, or critical value. So we just plug and chug. So that would be n is equal to 1.96 quantity squared times 0.66 times 0.034, and that's given in the equation. I mean, the problem, it says 66%, and it says over 0.03 squared, and that 0.03 squared, you do the math, that comes out to be all together 957.8, which is equal to 958 people. So you would have to have a minimum of 958 people to actually get a 95% confidence level based on the numbers that we've been given. So that's how we find a sample size. And that's a kind of a rundown on 7.2. Hope that helps.